Assalamualaikum and hello. Let's focus with the next physical properties of alcohols, which is boiling point. There are three factors that you have to understand when explaining the boiling point of alcohols. We are going to focus for the first one is number of OH group. When you have more OH groups in your structure, it means that the structure can form more hydrogen bonding with other alcohol molecules. So I emphasize the word more here, and please remember when you explain about boiling point, it means between one alcohol with another same alcohol. If you talk about the solubility, it is between one alcohol with water molecule. So that is the difference. So from here, we are focusing on alcohol with another alcohol. And from the third point, you can say that more hydroxyl groups in the compound contributes to higher boiling point. That is the first factor where for your structure, it must have the same number of carbon atoms but different number of hydroxyl groups. Next one, we go to the second factor, which is size of molecule, where for the size of molecule, it means that you are comparing between the structure with the same number of OH group. So when you have a larger size for your alcohols, means that it has stronger London dispersion forces that contributes to higher boiling point. So this is where you make it specific for your van der Waals forces, which is the attractive forces between alkyl groups in the alcohol. We are not talking about hydrogen bonding here because the number of OH group are same. So we talk about London dispersion forces. So if you want to understand more why we talk about London dispersion forces, for example, I got one butanol and I got one hexanol. So if you take a look here, one butanol got 4 carbon atoms, so I got 4 of them, and then at first carbon you got OH group. For one hexanol you got 6 of them, and then at first carbon you got OH group. So this is between one hexanol and one butanol. When we talk about the boiling point, it means that we are comparing between two same alcohols. So for one butanol, I'm comparing with another one butanol. You can see that I got another structure for one butanol. Same goes for one hexanol. And here, you can see that between one butanol and one hexanol has higher boiling point because it has larger size. This is with 6 carbon, this is with 4 carbons. Now, you can also describe that one hexanol has stronger London dispersion forces. Why we are not talking about the hydrogen bonding? Because the number of OH group for both compounds are same. So you can see that we're not talking about number of hydroxyl group. We are talking about the size of molecule. And now we are going to focus for the alkyl groups. These alkyl groups where they are the carbon chains in your alcohol. So from here, the London dispersion forces will form between these alkyl groups. So there will be attractive forces between alkyl groups based on the same alcohols where this area. So you can see that from one hexanol has a lot more attractive forces compared to one butanol. So these are the stronger London dispersion forces we are talking about. Now we focus for the last factor, which is the shape of molecule. For the shape of molecule, for example, you got branch alcohol. So branch alcohol contributes to smaller surface area in contact. So if you got smaller surface area in contact, so your alcohol will have weaker London dispersion forces, hence lower boiling point. So this third factor are referring to the same number of carbon atoms and the same number of OH groups. Settle for the three factors affecting the boiling point of alcohols. I need you to follow the steps one by one. First, you have to compare the number of hydroxyl group if it contains the same number, so you can compare the size of molecule. But if the alcohols still have the same molecular size, you are going to compare the shape of molecules. So that's why this is number 1, this is number 2, and this is number 3. For the next video, we are going to focus how to answer the example based on these factors. I'll see you in the next one. Thanks for watching and bye.